So let me ask you this question. Is it better to have more collision domains or less collision domains? Is it better to have more collision domains or less collision domains? Well, just by looking at this, is it better to have one large collision domain or is it better to have 3 collision domains? Is it better to have one large collision domain or is it better to have 3 collision domains? Well, with the one large collision domain, I see a collision happening. With the 3 smaller collision domains, I don't see any collision happening. If you're having trouble following along with the fact that more collision domains is better, think about this analogy. I run a daycare. I don't really. I run a daycare though. And we have 100 children in this daycare. Fantastic children. I love them. They're amazing. The problem is that we have one room with me and 100 children. What is the likelihood that 2 or more kids at any given time are going to collide? One giant room, 100 kids, one me. The likelihood of a collision happening is extremely high, isn't it? It is. So now let's create collision domains. Let's break this one large room up into 100 smaller rooms. That's right, 100 smaller rooms. Put each kid in their own room. What's the likelihood of 2 kids colliding at any given time? 0, right? It's 0. Every kid's in their own room and they're not allowed to talk to each other or play with each other or do anything with each other. Why? Because we're trying to prevent collisions. Okay, that's an extreme example because we would never do that to children, right? We'd never do that. But it's just a way to think about it. If we did separate all those kids, they're not going to collide with each other anymore. Same idea here. Let's put every single device in its own collision domain, and therefore we won't have collisions anymore. Now, there's another term on this screen, broadcast domain. Notice that the broadcast domain doesn't change. The broadcast domain is the scope of the local area network where broadcast can propagate, regardless of whether we are in our hub environment or with our switch environment. Notice the broadcast domain is the exact same. Exact same. So what is the broadcast domain exactly? The broadcast domain is really defining the boundary point where broadcast can go. So what is a broadcast? A broadcast is when a device blurts out information to absolutely everybody. So if I have a PC that wants to talk to everybody inside the local area network, it sends a broadcast out. And that broadcast is going to go to absolutely everybody. But the broadcast will never ever cross a router interface. Your broadcast will never leave your local area network, right? It's designed to stay in your local area network, to talk to everybody in your local area network. So the router defines the scope of the local area network where your broadcast can propagate. So here's a great example of using a broadcast. Your PC turns on first thing in the morning. You need to seek out a DHCP server to get your IP address, your subnet mask, your default gateway, and the DNS servers. 4 primary components of communication that are required on a day-to-day basis. Well, do you know who the DHCP server is? No. So what are you going to do? You're going to send out a broadcast. Hey, I need a DHCP server to give me some information. Well, you're just going to blurt it out on the entire local area network. And it's going to go to where? Everybody. Everybody. So our PC over here gets it, our router gets it, our server gets it. Let's say the server is the DHCP server. Well, only the DHCP server responds in that case. But would the broadcast have gone out? Would the broadcast have gone out past that router? No, because the broadcast would stop at that router interface. So the broadcast domains are defined by your router interfaces, and your collision domains are defined by your switch interfaces. So let's practice something here. I'd like you to take a moment to identify the number of collision domains that we have here. How many collision domains do we have here? How many collision domains? Remember what I said, every single port on a switch is in a different collision domain. Whereas with the hub, every port's in the same collision domain. So what's your thoughts here? How many collision domains do we have here? Take a moment, figure it out. If you want to, pause the video, figure it out. Once you figure out the answer, unpause the video, and I'll tell you what the answer is. All right. Do you have enough time? Let's look at the answer. How many collision domains do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9 collision domains in total. 9. Did you say 11? If you said 11, probably because you double counted these, right? Don't double count them. It's still one collision domain between two switches, right? So we have one here and one here, not two here and two here. It's one and one, one and one. And don't forget about the collision domain between your switch and your router. Now, how many broadcast domains do we have? Here's your bonus question. How many broadcast domains do we have? So we have 9 collision domains. How many broadcast domains? Yeah, just one, right? Just one. So look at the router interface we have here. The router interface that goes down to the switch in this case, well, everybody off that router interface is in the same local area network, which is the same broadcast domain. So if any one of these devices send out a broadcast, it'll go to absolutely everybody, even the router interface, but it will not go through the router at all. Even if the router had other interfaces, it would stay in the local area network to broadcast. So switches, let's focus on our switches here. Switches have very specific functions. First of all, they operate at the data link layer of the OSI model, which is also the what? The link layer of the TCP/IP protocol suite. We have our link layer, which is a combination of the data link layer and the physical layer of the OSI model. So the data link layer of the OSI model here. Switches are extremely intelligent, extremely intelligent. They have the ability to forward, filter, or flood frames based on entries that they have in what is known as a MAC address table. So there's this table on our switches that will contain MAC addresses. But more importantly, the MAC addresses will be associated with the specific interface that is used to reach that device. So all of our devices have a layer 2 MAC address, every single one of them, and they're going to use it to communicate on the Ethernet network. And the switches are going to learn those MAC addresses so they can understand where everybody lives inside that local area network. And then based on that information, they can forward, filter, and flood those frames. We can have full duplex ports, we can have half duplex ports, but in reality, we really want the full duplex ports. We really want the full duplex ports. Half duplex will be a nightmare for those of us that want to implement real-time application services. And one of the great things about our switches is that we have extremely modular control over these devices. What does that mean? It means that we can have switches with a small number of ports, switches with a large number of ports, switches with slow port speeds, switches with high port speeds, or we can have a big chassis with a combination of all these different types of port speeds and all these different types of interconnections that are necessary for our organization. So there's a lot of different deployment options that we have with our switches, but they're definitely high speed with various port speed options as well.